Okay, I was asked the other day, and I thought I would share what was the first project that I got when I started my consulting company. I had just gotten permission to teach at Georgia Tech for executive education. One semester later would come the MBA program, which I did for another 18 years. But I also wanted to start seeing my own clients. I had just left the Home Depot at that time. So I was approached by a company that offered DSL services. And if you recall, when I teach at Lean Six Sigma as simply being a detective for corporate America. So I like to use that terminology. So this project was the case of the 19% close ratio. Why do only 19 out of 100 people sign up for DSL service after calling the call center? So if you recall, we've got a measurable problem statement. Only 19% of people sign up. We need a goal, and so they decided they wanted to shoot for 25%. Now, in the data set later, I will determine if that's actually achievable. So now I want to go to the measure phase, and I want to ask, where's the data? Do we have good data? And they said, well, we can give you the average close ratio per month. That would give me 12 data points for a year. I said, can you get it weekly? Absolutely. So that would get me 52 data points. So the point here is always get the data at the lowest granular level possible that the system will give you. If you have to mathematically manipulate it, such as divide 52 by 4, that's not raw data. Well, I was very fortunate that they could give me the daily close ratio. So there was some science behind what we decided, but basically we ended up with 120 data points. Okay, and the data would look like, 0.19, 0.18, 0.25, 0.15, etc. Okay, so that is my Y metric. My Y metric was the percentage of people that signed up for DSL service per day. I also asked what X variable should we look at it by, and we decided to start off by looking at location. Okay, so location, and that time they had 3 locations. So we went and got the raw data, and there's only a certain amount of charts you can do in the measure phase for continuous data. And one was, of course, the famous control chart. And I'm not going to draw it perfectly, but I do want to highlight that there were some patterns like this. Again, this is just an example, not the real data. I also got it by location. So I have a continuous Y, the close ratio, and I have a discrete X, Jamaica, San Antonio, Texas, and Bartlesville, Oklahoma. Those were the 3 locations. So when we did that, if you remember, a box plot is for when you have a continuous Y and a discrete X. There was a clear difference in the close ratio by call center. Jamaica was about 10%. San Antonio was about 18, and Bartlesville, Oklahoma was up with a median of around 22. Okay, so we've got a quick win here. The client decided to close Jamaica. And now because of the graph, by the way, these are just basic graphs that companies aren't doing. They are at most taking raw data and putting it in an Excel line chart. So because of the box plot, they can now see that they should divert the calls to Bartlesville, Oklahoma. I bring that up because this was one vendor. We'll call this vendor A, and this is vendor B. So we've got a quick win. Send the calls from Jamaica, who's only closing 10%, to Bartlesville, Oklahoma. Also then the client, just using this simple graph, decided we want to close this provider. But I learn, and I always learn something from my clients, you don't want to put all your calls in one basket. So they wanted to look for another provider that had conditions like this one. So I'll come back to that in a second. The other thing we noticed were these crashes in the data. And so, this is the wonderful thing about historical data. We were able to go back and find out that the call center system went down. The order taking system went down. Now, IT knew that, and they said there's no budget to fix it. But the reason they thought there was no budget to fix it is because they thought the close ratio immediately came back up the next day. But what the data showed is it took 2 to 3, sometimes 4 days for what we assumed was people to get their motivation back. Remember, they're paid a commission on sales, and you have a whole day where you sell nothing or almost nothing. You're not very motivated, apparently, to get to selling again. So when we said, IT, your hypothesis is wrong, this is how much you're losing in sales. Again, they thought it jumped right back. We showed it took a lot longer. All of a sudden, the money was there to fix the IT system. So we've already found some X's. X1, the call center system going down, is one of the reasons we're not getting more than 19%. And so if we can fix that, and now the money's there because they realize it's not coming back. X2 was vendor. All right, vendor A underperforms vendor B. So now we get to the improve phase, and of course IT would take this and start fixing the call center system. But this was interesting. How do we get a new vendor B? So what we did was one of my favorite tools, the is and is not matrix. What is true about vendor B that's not true about vendor A? Can we develop a recipe, basically? Can we get some descriptions that we could use for an RFP to find a new call center? So let's make this Bartlesville, Oklahoma, and let's make this San Antonio, Texas. So San Antonio, Texas has a high call center population. In Bartlesville, Oklahoma, it was just these folks. Because it's a high call center population, you had high turnover. Because why not? If you are used to working in a call center and someone will pay you 20 cents more an hour, jump. Bartlesville, Oklahoma had almost no turnover because what we found out was this was near a military base. I'm just abbreviating. And this was considered a very good job for military spouses to have. It's hard, I'm ex-military, it is often hard for spouses to find jobs in a military base area because there's just not a lot going on. There were some other things. You hot desk at this client, meaning third shift comes in and takes over the same exact seat as first shift or second shift. And this one, everyone had their own desk. So there were quite a few things that stood out from us, but basically we put out an RFP that said, we want a call center that looks something like this, and the client ended up getting one near what was then called Fort Bragg, North Carolina. Did it work? Well, we can use the same tools in the measure phase. We've got our little control chart. Let's just say I'm going to use this last part, right? We've got the crash, we've come back up. Did it work? Yes. The new average got up to about 25%. Another thing that we could do, vendor A, the new vendor A, vendor B, right? So that worked. And I'm told, by the way, now how long did it take me to solve this? I charged the client, this is amazing, 6 billable days. 6 billable days. Now there was time in between this. You know, they had to gather the raw data, they had to send it to me. The graphs were super easy to do in my favorite software, Minitab. I had a great client that was willing to be in meetings. We flew to Bartlesville, Oklahoma together. The bottom line, though, is 6 billable days, you know, is not going to be a whole heck of a lot for, I believe they said it was about a $2.5 million annual gain in sales for this project. So certainly for me, it looked great on the resume. The client ended up bringing me back 4 or 5 times to do Greenbelt training for the employees so that they all knew how to do this. But this was my first project, the case of the low DSL close ratio in the sales call center. So by the way, this blows up the myth that Lean Six Sigma is for manufacturing only. Or you could say a salesperson is a manufacturer of contracts. But either way, it was an awesome project, and I wish I had kept a copy of the check and framed it for when they paid me.